Okay, today I decided to record the lesson. It is Tuesday, 12/13, and we're continuing on 4-1, just because we have a lot of people gone. So these are the two problems I asked you to do right at the end of the hour, just to kind of go over them. So this one is 9 pi over 4. So if you think about dividing 4 into 9, that does go 2 times. That's 8 and 1/4. So we can kind of think of this as 2 pi plus pi over 4. And so that's kind of another way to think about that one. And if I graph that, just to kind of get an idea of what's happening, pi over 4 would be kind of right there. And so what I've done in this one is I've gone 8 pi over 4, which is the 2 pi, plus an extra pi over 4. So that's what gives me that 9 pi. So I might even write that 8 pi over 4 plus pi over 4. And so that tells me that positive, or that is one spin and then a little bit more. So one way to get our positive angle is, one positive is to just take, since this is already a complete spin, is to take the 9 pi over 4 and subtract 2 pi. So 9 pi over 4 minus 8 pi over 4, and getting that pi over 4. So that's a positive. The other way to get the positive is just to take 9 pi over 4 and add 2 pi, just to get a bigger value. So 9 pi over 4 plus 8 pi over 4. So 17 pi over 4 would be an acceptable answer as well. You know, as you could add, 8 pi, and because that would be like 4 revolutions and still get a positive. So generally people pick one of those as their positive. And then for the negative, once you get down to this pi over 4, so that's just that one angle right there. To get your negative, you're going to subtract 2 pi from that. So to get our 1 negative, we'll take 2 pi minus pi over 4. And so you do have to get down to that, like, first angle within 0 to 2 pi in order to go then to the negatives. So 8 pi over 4 minus pi over 4, which is, oh, just a second. I did that completely wrong, even though I, in my head, had it right. Really, we have to take pi over 4 minus 2 pi. So pi over 4 minus 8 pi over 4. And then we get negative 7 pi over 4. So there would be our negative value. And that's generally what people get for the negative value. So 9 pi over 4 was the original, right? But when I subtracted 8 pi over 4 the first time, it's still positive. So that can be my positive answer. But then to get a negative answer, I have to continue subtracting. Well, because if I would have used it again, I'd subtract 2 pi to get it to this, and then I'd still have to subtract 2 pi again. Does that make sense? So then the next one is negative pi over 3, so it's already negative. So if I subtract 2 pi, I'll get another negative. If I add 2 pi, I'll get a positive. And so let me just kind of get that. So negative pi over 3 plus 2 pi, which will be negative pi over 3 plus 6 pi over 3. And so 5 pi over 3 is what I get. That's my one positive. And then my one negative, since that's already negative, I can't use that one, but I'll just subtract from negative pi over 3, I'll subtract 2 pi. And so negative pi over 3 minus 6 pi over 3. And so I get negative 7 pi over 3. So there's my one negative answer. And you'll notice that in the process, I'm usually finding that smallest positive angle, and that is an angle that we want to be able to kind of have in our heads, because if I wanted then the general answer for all angles that are coterminal, in this one I would use this 5 pi over 3 because that's the positive angle, and then plus 2 pi n. And in this first one, I would have used the pi over 4 plus 2 pi n. And so getting down to that smallest positive angle can be beneficial as we do that. So do you remember what complementary and supplementary angles are? Complementary angles add to be 90 or pi, or excuse me, pi over 2, and supplementary add to be 180 or pi, right? And so that is going to be the next slide when I find it. Oh, two positive angles, alpha and beta, are complementary or complements of each other if their sum is pi over 2, and two positive angles are supplementary if their sum is pi. So complementary angles, they add to be complementary. Their sum is pi over 2, supplementary, and their sum is pi. So that should be pretty straightforward for us. And we know in degrees that would be 90 degrees and 180 degrees as well. Now, sometimes we're given this direction: find the complement and supplement if possible. So if it's over pi over 2, it wouldn't have a complement, correct? And if it's over pi, it won't have a complement or a supplement, right? So sometimes we can find one, but not the other. And sometimes we can't find any. So that's our next problem, is just finding complements and supplements. So find the complement and supplement of the following angles. So the first one is pi over 6. And since complementary angles add to be pi over 2, to find the complement, um, and I'll just write comp, we take pi over 2. Oops, that's not going to be a 2. Pi over 2 and subtract the angle, minus the angle. And so pi over 2 minus pi over 6. We'll know, even, if we don't recognize that won't work, we'll know if it won't work because if we can't get a negative angle, okay? It's going to be two positive angles that give me that. So I'll get the common denominator, which is 6, and so I'll multiply by 3 over 3. And so I have 3 pi over 6 minus pi over 6, which is 2 pi over 6, which is pi over 3. So pi over 3 is the complement, And then to find the supplement, SUPP, I'll take pi minus the angle. So for this one, pi minus pi over 6. So pi is just 6 pi over 6 minus pi over 6. So 5 pi over 6. So, and I'll write is supplement. And then I do have this next one on here because you will encounter problems where you can't get both of those answers. So remember to find the complement. For the complement, we take pi over 2 minus 5 pi over 6. Well, pi over 2 is the same as 3 pi over 6 and minus 5 pi over 6. So we get a negative. And so we'll say that there is none. So there's no complement there. Because pi over, no, well, because if I subtract 2 pi minus that, and so 2 pi always has to come first. So think about it this way too. This is 0, this is half of a pi, and that's 1 pi. So if I was doing that, half of a pi would be 3 pi over 6, so 5 pi over 6. This angle is someplace over there, right? And so it's already obtuse, right? So it doesn't have a complement. It's too big to add to be 90. And as long as you always do pi over 2 as the first thing, because sometimes we get in a hurry and we just take 5 pi over 6 minus pi over 2, which would be a positive answer. So just be careful that you're going in the right direction, always having that pi over 2 first. And then the supplement is just pi minus 5 pi over 6. So 6 pi over 6 minus 5 pi over 6, which is equal to pi over 6. So it has a supplement, but it has no complement. It had a supplement, but it does not have a complement. So we started with radians, which is probably less familiar to you than degrees. We'll move to degrees next, which are a little bit more comfortable for us. But I will tell you, if you can develop a sense of understanding radians like you probably have of degrees. Do you know what I mean by that? So like on this little coordinate axis, when you think about 90 degrees, oh, that's to there, right? Well, can you in your head say, oh, that's also pi over 2? You know, so if you get kind of a sense of some of these, that will help you as you go. So the next section is on degree measure. This is still 4-1. Yeah, 4-1 is kind of long, and we'll still be working on it, I think, tomorrow. So degree measure. The second way is in degrees, and we do use this symbol for degrees, and it's equivalent to a rotation of 1/360th of a complete rotation about an axis, a vertex. And to measure angles, it's convenient to mark degrees on the circumference of a circle. And so this circle in this picture could have any length radius. It really wouldn't matter. And I gave you a handout with a bunch of degrees and radians on them. So that's just kind of to remind you. And we're familiar with that, and we've kind of gone through the whole revolution. So one full revolution corresponds to 360 degrees. Half of a revolution is 180 degrees. A quarter of a revolution is 90 degrees. And so since 2 pi radians corresponds to 360 degrees, then 180 degrees in matches with pi. And you don't really have to write this down because it's going to be on the next slide, the kind of rules here. And then, so 1 degree is pi over 180 radians, and 1 radian is 180 over pi, degrees over pi. And so, which leads to these conversion rules. These are the rules you want to know. So to convert from degrees to radians, you multiply the degrees by pi over 180 radians. And to convert from radians to degrees, you multiply the radians by 180 over pi radians. And this is the basic relationship that is in there. Pi radians is equal to 180 degrees. And then they just give you a bunch of little pictures. I don't care, you know, you can look at them or write them down or not. You have those nice circles with both radians and degrees on them, so you're good to go. Now, a rule of thumb is generally if there's pi in the angle, Then we're going to use this one because we want the pi's to cancel and then it'll be degrees. And if there's no pi, we usually use this one. That's a rule of thumb, but you do have to be careful because now we're at a point in our mathematics where sometimes we will have a degree measure with pi in it, or we will have a radian measure without pi in it. So it can be a rule of thumb, and so when in doubt, you can do that, but you do want to kind of look at things and kind of see what you're going to end up with. So here is when no units of angle are specified, then radians are implied. So for instance, if theta equals 2, that implies that it's 2 radians. And so we're used to seeing radians have pi in it, but it doesn't have to have it. So just kind of be aware of that. And let's kind of just look at that. So if theta equals 2, that implies that theta is 2 radians. So let's just take a minute and convert 2 radians to degrees. Oh, 2 degrees. And so since that is radians, we're going to multiply it by 180 over pi as our conversion factor. And so then we get 360 over pi. And now that it's in degrees, we want to put that degree symbol there. Now, the other thing we want to know about what we're looking at is changing things into degrees, minutes, and seconds. And that's something where you're going to have to know a little bit down the road, but I usually just introduce it right now. And so on a clock, 1 hour is 60 minutes and 1 minute is 60 seconds. Do you agree with that, right? Well, the reason I say that is because when we're looking at degrees, think of that as a full hour. And so a degree has 60 minutes. It's just like a clock. It has 60 minutes in it. And um, a minute has 60 seconds in it. So a degree has how many seconds? $3,600. So think about it this way. A degree has 60 minutes in it, right? So you've got 60 minutes. Every minute has 60 seconds. So it's 60 times 60. And so that's how many there are. And the notations for that is 1 minute is like just a little hash mark. And I'll write 1 minute. And that's equal to 1/60th of 1 degree. So 60 minutes equals 1 degree. And then 1 second, which is 2 hash marks, 1 second is equal to 1 over 3,600 of 1 degree. So there are 3,600 seconds equals 1 degree. And it's kind of that 60 times 60. So I think these little calculators don't have degrees, minutes, and seconds on it, but somebody could, dispute me on that. I don't really know. And if I have time today during lunch, I'll kind of look at that. But I know that your graphing calculators have degrees, minutes, and seconds on it. And when we do that, some work there, we will be using those graphing calculators to do that. So I'm just going to put this one on here so we are introduced to it right now. So if I have 64 degrees, 32 minutes, and 47 seconds, I can convert to decimal degrees. And the way that I do that is I'm going to take and say this is 64 is the whole numbers, plus this is 32 out of 60 degree, 32/60ths of a degree or whatever, and 47 over 3,600. And then I just type that in a calculator and it's approximately 64.546. And the buttons you're looking for on a calculator are MDS, and sometimes they have a little dot and a slash and two slashes. And so maybe that is on these calculators. I'll try to look between today and tomorrow. But that's just a little extra thing to think about right now. What we really want to just do is not this at the moment, but we want to convert to from degrees to radians. And so I'm just going to write this problem on here. So 135 degrees, you're going to take 135 degrees times pi over 180. And generally, we want to reduce that fraction. So 135 pi over 180. Oh, that was degrees. So the degrees kind of cancel themselves out. And we usually want to reduce this fraction. And does this, that's another question I'm not sure of. If this, oh yes, if you do that print, right, or math print, do you know what I'm talking about? Under mode, I think it is. And it'll reduce that for you. But I happen to know, I think 45 goes into both of these. 45, 1, 2, 3, 4 goes 4 times there, and 45, 90. And it goes 3 times there. So 3 pi over 4. We keep it intact with pi because, and I'll write radians. The nice thing is if you forget to write radians, that's okay because it's really unitless, but you do want to have degrees if you're converting to degrees. And the nice thing about leaving in terms of pi is that's an exact value, correct? Because pi is irrational. And so 540, we'll change that. 540 degrees times pi over 180 degrees. So 540 pi over 180 pi. And let's see, I think 180 goes into 540. 3 times 0, 14, no, 2, and 5. Yep. So that's equal to 3 pi. So unless we're asked specifically to change it to something else, we just convert it right into to radians, leaving pi in there. And I can label that as radians as well. So then next we'll convert from radians to degrees for our next ones. And let me kind of find where they are. Here we are. From radians to degrees. So what am I going to multiply if I'm converting from radians to degrees? 180 over pi. And so negative pi over 2 times 180 over pi. And again, general rule of thumb, usually if it's in radians, it will have pi in it, not always. But if it does, then we can just cancel the pi's. And so this is negative 180 over 2. So it's negative 90. And so like I said, this one doesn't have the this doesn't have, oh yes, I'm sorry, yes, thank you. And that's negative 90 degrees. And I should have had the degree thing on there as well. And then the pi's just cancel. And radians don't even have to be written there. So 2 radians still would have like the pi on top. And so we take it times 180 over pi. And so for this one, we get 360 degrees over pi. And if needed, we can get a decimal approximation for that. Somebody tell me what that is to 2 decimal places. 114.59. And so Now that's in degrees. Now, I think, introduced this idea last time, but now we're going to do some problems with it. So we have a little paper. This is our application section of this section, part of this section. So the radian measure formula is this theta equals S divided by R, and it can be used to measure arc length along a circle. And so we'll kind of do things like revolutions and all kinds of stuff. So arc length for a circle with radius R, central angle theta, and intercepts an arc of length, so the arc of length S is the intercepted arc, is this formula, S equals R theta. And we kind of talked about that whole triangle concept. So S divided by R is theta, S divided by theta is R. And the deal here is theta has to be in radians. It has to be in radians. If it's not in radians, you're not going to get the right answer. And then also note that if R equals 1, so that's going to be called a unit circle when the radius is equal to 1, that S equals theta, and the radian measure of theta equals the arc length. So if it has that nice little 1 radius, then we're kind of good to go. So since I'm recording today, I think I'll do this first problem is maybe a little more straightforward, or I'm not 100% sure I can get it written or done. So instead, what I think I'll have you do is write this problem so that you kind of have what it's asking for, and then we'll probably just go over it tomorrow. So a circle has a radius of 4 inches, and they have this huge picture here, which is wonderful. It has a radius of 4 inches, and we want to find the length of the arc intercepted by the central angle of 240 degrees. And there is the huge picture that we're working with. So we'll let you do that. We'll do that problem tomorrow.